So yesterday we focused on functions. So I want to go back, before we jump into arrays, I want to go back to objects.js and I want to update the object that we defined up here with our JSON to show you like what does it look like to add a function to an object. So here's what that can look like. So we already have this journal entry here, and we have the JSON to define the date property, the competency property, and the content property. We're going to add one additional property, which is a function defined for this object. And so the way we do that is we write the function name. Let's say I want to be able to get the length of the content. I don't know. That's a little arbitrary. We can have a function get length. So we have the function name. We have the parentheses here. There could be parameters. We have the curly bracket just like we would for a function definition. And then we can say like return this.content.length. What you notice here is that this refers to the object similar to Java. So the this keyword still applies in JavaScript like it does to Java. So inside of a function declared for an object, when we use the word this refers to this object, the object in which this function is defined. Cool. That's all it takes to add a function to an object, and then we can invoke it. Let's add another line here. We could say console.log journal entry dot get length. And so we use the dot notation not only to access properties, but to access functions, just like we do in Java. Okay, so again, lots of similarities with Java. All right, so I wanted to go back and add that because I think that's a useful addition. All right. Oops. Do that later. Let's take a look at arrays. So arrays in JavaScript have some similarities, but also some differences compared to Java. I think they're maybe a little bit more similar to Python lists than Java arrays, but there's still a lot of overlap. So let's focus on the syntax here first, and then at the end we'll see some really cool stuff we can do in JavaScript with arrays that's like super convenient. So first of all, how do we create an empty array? Create an empty array. We would say we're going to focus on fruits. Let fruits equals. So we use square brackets as array literals. Okay, so we saw yesterday that we were using curly brackets for object literals. We use square brackets for array literals. So this creates an empty array and assigns that reference to the variable fruits. We can also create an array with elements like already defined. So this is similar to like what we can do with array literals in Java. It's just that the syntax is different. So we still use the square brackets, and then I can list each element in the array: apple, banana, cherry. Our elements are just strings. We can put anything in an array. We can have an array of objects as well. So I would say this syntax is similar to what we're used to with Java. It's just that we've got the square brackets instead of the curly brackets. So a little bit of a small syntactical difference. Other things that are similar. Arrays are zero indexed, like Java. So I can say console.log fruits.1. and that's going to print banana. So that's just like Java. All right, so we'll go back and forth between things that are like Java and unlike Java. So here's an unlike Java thing. Elements can be added to arrays. That's super convenient. That's unlike Java. We can't do that in Java. So I can say, and this might seem weird, and I'm not sure why this would be useful, but I can say fruits sub 10 equals date. Not only have I added an element to the array, I skipped a whole bunch of like indices, right? Because apple would be index 0, banana is 1, cherry is 2. I just put date at 10. So let's actually look at like what does that do to our array? So let's log fruits. And specifically, let's log fruits sub 8. So go ahead and run that. See, what does it look like when we log an array? What does it look like when we log an array that has not every element defined? And what happens when we try to access an index that we haven't assigned anything to? So let's see the answers to all those questions. So I think it does a great job. Apple, banana, cherry, 7 empty items, and then date. And specifically, when I tried to say, okay, what's the value in the fruits in the array referenced by fruits at index 8, it says it's undefined because we've never assigned it anything yet. So this behavior is quite a bit different than Java, right? We're not getting like array index out of bounds exceptions, things like that. Actually, that's a good question. What if I say 12? Same thing. Okay. So no array index out of bounds exceptions. That's great. All right, here's another similarity. We can use dot length to get the number of elements. That's like Java. We're used to that. So I can say console.log fruits.length. And the length of this array is now 11 because I added date at index 10, which means there are 11 elements since we start at 0. All right, something unlike Java. This is convenient, kind of. Elements can be of any type. That's unlike Java. So in Java, we can have an array of ints, we can have an array of turtles, we can have an array of strings, but we can't have an array that has both references to turtles and strings and ints all in the same array. But in JavaScript, no problem. So let's make another variable, and I'll show you. We can say like the first element is a primitive number, the second element is a string, the third element is a Boolean, the fourth element is an object, and the fifth element is itself an array. I have no idea why you'd want to do this, but you can. And if you run that, you can see it prints it all really pretty nicely. Yeah. Oh, good question. I guess I'm making it of type const because I don't know if I have my warnings set up here. I'm not going to change the value of the variable. So if a variable doesn't have its value changed, it's best practice to make that like explicit by marking the variable as const. versus let, where it can be changed. And something must not be quite right with my linter or something here, because it should generate a warning if I were to leave it this way, but something's off. Like I should get a warning saying, hey, this variable's value is never changed. You should declare it const instead of like let. So when it's printed, again, we'll see the square brackets are used when it prints the array. This is also JSON format. So when we want to declare an array in JSON, we also use the square bracket. So it's all consistent, which is great. Here's the object being printed. Here's the array inside of the array being printed. Again, all JSON format, which is neat. Very cool. All right. Here's another difference with arrays in JavaScript that makes them powerful. Arrays have methods like stacks and queues. So in Java, we don't have any methods on arrays, right? There's the special .length thing, but that's not a method. We can't call any methods on our arrays in Java. We can call methods on things like stacks and queues and lists and things like that. In JavaScript, we can call methods or functions on our array. So I'm going to give you just a few examples of some of the most common ones, and then you can always explore others as needed. We can use .push and .pop to treat an array like a stack, meaning it's going to be really fast to push and pop onto the array. So we can say like fruits.pop. Wow, we can try if I can type. There you go. That will remove the last element. We can say fruits.push and add another fruit. That adds the element to the end. So like in the maze lab, when we implemented our stack for the maze lab, and we used an array list internally, we got the highest performance when we added elements to the end of the array list, pushed elements to the end of the array list, popped elements off the end of the array list. These methods do exactly the same thing. So now when we run this, we're going to see the last element, date, has been popped off. Elderberry has been pushed on. So the top of the stack is the end of the array. And we can use our JavaScript arrays just like stacks. We can also treat an array like a queue. We use pop, same method, to remove from the head of the queue and unshift, which is slow, to add to the tail of the queue. So in Java, when we want to implement a high-performing queue, like we did in the maze lab, we implemented it as a linked list. So adding both the in-queue and dequeue operations, adding to the head of the, or removing from the head of the queue and adding to the tail of the queue, both were fast. Here in JavaScript, fundamentally, it's still an array. So pop will continue to be fast to remove from the head of the queue, but unshift is going to be slow because it's got to shift all those elements. So here's some examples. Fruits.unshift apricot. Is unshift the way we do things in Python too? I think so. Does that ring a bell for anyone? I think these are similar to the Python methods too. add the element to the tail of the queue, fruits.pop, remove element from the head of the queue. And then if we log this, we can see what that looks like. So unshift added apricot to the tail of the queue, and then the pop removed elderberry from the head of the queue. So the head of the queue is on the right of the array. The tail of the queue is on the left from the perspective of when we log stuff. So just keep that in mind as well. Pop will always remove the element from the end of the array, which we treat as the top of the stack, but that's just our construction, right? That's not part of the array. And it will therefore also pop from the head of the queue. But again, that's just our construction. It's nothing built into the array. It's just the way we choose to look at the array, right? The end of the array is we choose to look at it as it's the head of the queue and the top of the stack. And so pop always removes that element. All right, some other cool and familiar JavaScript features. We can write for of loops. What I mean by that is we can say for const fruit, fruit of fruits, console.log fruit. This is like the enhanced for loop in Java. This is like the for loop in Python. Very, very similar. We write a lot of code like this when we need to iterate through an array. So there's all the values there. All right, before we go on to the next topic, let's just pause a moment. What questions do you all have at the moment about arrays before we do the next part? Yeah. Yes. So when we use the for loop, it's going to go from the element at index 0 up through the end of the array. And the element of index 0, the first element in the array, if we're thinking of the array as a stack, it's going to be the bottom of the stack or the tail of the queue. But again, those are just constructions. We just choose to do it that way because it maps to the data structures that we're familiar with. And it gets us like the best performance we can given that it's an array. Like we could totally write like a more typical for loop, like where we go through all the indices, like I equals 0 type stuff, but we just don't normally do it that way. All right, so in chapter 16, I think, 15, in chapter 15, we learned about the map method. Did we? Maybe it's the merge method. When we were learning about Java lambdas, I think we focused on merge to see like, okay, how do we use a Java lambda? How do we pass that to a function that performs an operation on like our list or map or whatever it happens to be? We're going to explore the same thing now in JavaScript. I thought it was important to introduce you to that concept in Java. We didn't use it a lot in Java. We're going to use this all the time in JavaScript. So we're going to build up to this like incrementally. We're going to write some code together that will be familiar, and then we're going to revise it to be less familiar, but more concise and more typical about what you're going to see with JavaScript in general. So a lot of times in our web applications, looking ahead to next semester, we might get like an array of strings, maybe from the database or from like the user interface of our web app, whatever it happens to be, and we need to turn them into objects, right? Because we really want them as objects because we're going to save them to the database, or do some processing on them. And so we could write code to iterate through every element in the array, which is a string, and then for each one, build an object and put that in a new array. We're going to see there are more convenient ways to do that in JavaScript. But our first approach is going to be to define a function, which will create an object from a string value. So this function will create an object from a string value that will be assigned to the name property. So we learned how to write functions yesterday. This function's name is going to be create fruit object from name. It takes one parameter, which is the fruit, the item, and then it's going to return a new object. So I'm using the curly bracket object literal syntax. And it has one property, which is the name. And the value of that name property will be whatever the item is that's passed in. So there, we've defined a useful function. We will now write a function called map. So the idea of our map function is, let's just write it. So function map, it's going to take one parameter, which is the list of strings, the list of fruit names. That's our array. And we're going to return a different array. So that will be the result. We'll initialize it to an empty array to start. And then we can use our for loop. We can say for each item in the list, we're going to push onto the result the object returned from calling create fruit object from name. And then we'll return that. There, we can see it all on the screen at once. Oh, great question. So the question is, when I declare the variable result, shouldn't this be let and not const? The value of result is not changing, because the value of result will be a reference to the array. And I'm not changing result to refer to a different array. It's always referring to the same array. I'm just adding elements to that array. So it's like in Java, we could have a variable of type final that is an array, and we can like change the values of the elements in the array. We just can't change the reference to the array itself. So similar concept.
So if you were able to do like, are you able to do like result of one equals create fruit object from name instead of return
Instead of here? Yes. But I mean, we would then need like an index variable, right? And we'd do like 0, 1, 2, 3, 4. Yeah, even though it's const, yep. Yeah. Great questions. All right, so this idea of a map is very useful. We use this a lot for creating an array of objects from an array of values. I think that's one of our most common pieces. So we could create a new variable like fruit objects, and we could say fruits. Actually, let's just pause. We'll pause there for a second. All right, because we're going to get an error here in a moment. So I wanted to type this because I wanted you to see that what this map function does is it makes an empty array. It iterates through every element that was passed as an argument. It then calls some function for passing each element along, which is the function we wrote up here, takes the result of that and pushes it on to the array that's going to be returned, and then eventually it returns that array. We don't need to write this function because it's already built into, it's already a function defined for arrays in JavaScript. So I'm going to hit Control/ on Windows or Win/ I think on the Mac and comment this out because I want it here for reference because it's important that we can mentally trace through this when we start using the built-in map function. So I can say something like fruits.map, the map function is already defined. And then what it takes is a parameter. It's a little bit different. The map function that's already defined has all of this. I don't need to pass the array because I invoked the function on the array. I do need to pass the function that will be called for each element. No, so I'm passing here a reference to a function as a parameter. Notice there's no parentheses after here. I'm not invoking the function. I'm just passing the reference to the function to the map function so that it can call it when it needs to, and it can call it over and over again. This is exactly what we did with the Java lambdas. So I think we were doing the merge method, if I remember, in our practice programming activity, and we passed a Java lambda to the merge method in the same way. So let's log this so we can see that it works. And we can run it. And now you can see when it logs the array, it's now an array of objects. Each object has a name property. It's been assigned the different fruit strings. Cool. The fact that there were some empty elements, no problem. They're just now empty objects. It all just works out. JavaScript can be very forgiving in a way. All right, we wrote it this way by writing a function and by seeing exactly how map works because I wanted you to be able to connect that. Here's how we normally write it. We use arrow functions again. So arrow functions are typically used in these cases. Here is the previous example using an arrow function. So this is going to do the exact same thing, but I want you to be able to compare and contrast the difference. I can say fruit objects equals fruits.map. That's the same. I'm not going to specify the function name. Instead, I'm going to put the arrow function right here. So the function needs to take one parameter, which is the individual element in the array. Here's my arrow operator. And what gets returned, remember with an arrow function is if it's just one line of code, I don't need curly brackets. I don't need the return keyword. I can just put in parentheses like the expression. And what I want to return is the object literal name with a value of item. So this line of code does the same thing as this plus this function. So that all gets replaced by the arrow function instead. So you can see this is super concise. And we tend to write code like this in JavaScript all the time. It takes some practice and some getting used to. And we'll do some peer instruction in a moment. And we're going to do to focus on this in particular because I think it's a little tricky. And then we'll also, of course, do some warm-ups in future classes too. Let me show you another example. So let's say we wanted to capitalize the first letter of all of our fruits and build a new array with that. I can create a variable called cap fruits, and I can say fruits.map, and I can specify a different arrow function. For each item in the array, we're going to return item.toUppercase. That's a string function we can call. One thing I'll point out is you'll notice we had to have parentheses here because we wanted to distinguish between this curly bracket being the start of an object literal versus like we're doing a whole like function body. Okay, so that's why we have the parentheses here. Here it's not ambiguous, so we can simply just say item.toUppercase. It'll invoke the uppercase function on the item. The value that's returned will automatically get pushed into the new array. So we can log this. And sure enough, when we run this, all of the fruits are now in all capital letters. Great. Sometimes we want to go the other way too. So we can do all of this or the other way around. What I mean by that is we could log console.log. We'll just do a log. I can start with fruit objects. I can say map each item in fruit objects to a new array where each element is simply the value of the name property. I left something out here. Map item. There you go. And if I run this, the last thing that will be logged to the console is just an array where now it's just the string values. We don't have the objects anymore. Super, super convenient. All right, so thinking this is just a brief introduction to arrays, there are other array methods which are really helpful. Here are some of what I think are the most helpful ones. Splice, that might bring back memories of Python. Slice, also Pythonish. Concat, those are some helpful array methods. You can also use things like index of, includes, find, and filter. Filter is great. It's like I have this whole array of objects. I call filter on it. I specify a condition. I get a new array where things have been filtered to only the things that meet the condition. Super convenient. You can also do stuff like sort, split, join, and reduce. So many methods. You can look all of these up on MDN, Mozilla Developer Network site. You can also look them up. I listed a JavaScript reference in our extensions or extra practice on our Canvas page. More resources there as well. Being aware of all of these different functions is a great investment because you can save so much coding time next semester and so much debugging time next semester by using these functions instead of writing tons of code on your own to do the same thing. We're not there yet, but we'll also get to the point where we start chaining these functions together. So I might have an array of objects, and I might be like, whatever my variable is, competencies.filter, and I specify a condition, and then I do dot map, and I turn it into something else, and I can just do one after the other, all on the same line of code. Crazy stuff.